Hi everyone, welcome to another video, and in this video we're going to solve a question called merge sorted array. So this is a straightforward question if we have to just merge to sorted array, but the question is a little bit tricky and we're going to understand that. So let's discuss that on the whiteboard. So the question is given as like we have nums1 as one sorted array, that is like 1 2 3 0 0 0, and then m equals to 3, and then another input like nums2 given 2 5 6 n equals to 3. See, in our normal merge sort, we just have to create a new array, and then we're gonna start a pointer here, start a pointer at I of nums2, and then we're gonna just compare what is it's smaller. If a 1 is smaller, we're gonna push 1 to the array and increase I pointer, and then keep comparing, and then we're gonna push 2 and 2. Then you're gonna move your pointer to here, then we'll see again 3 is smaller, so you're gonna push 3 and increase this pointer, and so on. But here the problem is it asking us to sort it in the num1 itself. So one way you can do that, like we kind of get this array and then again run a iteration and replace num1's values with the result array values. That will solve, but that is not the ideal solution. But let's do it first and see because at the end this merge sort logic is the core logic. So let's try to implement this first and we will see. So in our normal sort, right, normal merge sort, we're gonna create a result array. Let result equals to a blank array, and then we're going to iterate through num1 and num2. Here the m and n are the length, so we have to compare that, right? So while we're gonna initiate our I and j to 0, I and j equals to 0 0, while I less than m and j less than n, if nums1 of I less than nums2 dot j. In this particular case, we're gonna push result dot push the smaller one, that is nums1 of I, and I will gonna do I plus plus. If not, else result dot push nums2 dot I and j plus plus. This should push all of our values to our result array, but at the end there should be some residual values either in nums1 and nums2, so we're going to push that as well. So result dot push your dot 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 nums1 dot slice I, then m dot 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 nums nums2 dot slice j n. So this should give our result. Our result should become the required result. So return result, and let's run our test cases here that I have written. But again, this test case will fail on our lead code, but to test here we can run it. Get stuck. Okay, now run test. Let's see what has failed. Oops, sorry, here is the, we have to push a J. So it passed. So that is our normal merge cert, but here it is not asking to merge like that. It's asking to, for example, if you see the question, right, in the question it asks to do the merge in the nums1 array itself with replacing the values without taking extra space. That is the challenge in this question, but basically we can convert this answer into like for each and then result, then we're gonna write el, then I, then for every nums1 of I equals to el. Right, this will solve our like question, but this is not an ideal solution because this is not what it wants to do. But let's try this solution. Okay, we can copy that. So it passed. It passed all the test cases. But this is not an ideal solution. Let's see what is the ideal solution. We're going to implement that. Okay. Since it asks us to do it in num1, there is a hint in the question. The hint is like these 3 zeros. If you see the question, the array 1 has 3 zeros at the end. So definitely we have to do something with the zeros, because the question gives us a hint. So what if I will keep replacing these zeros with correct numbers? And how we gonna do that? See, we're gonna start our iteration from the end of the array where it's given, because n and m are given already. So you're gonna start here from n, you're gonna start here for m. Now we're going to compare these two. We're going to see which is which of those are bigger. That is 6. So I'm going to put 6 here and I move the pointer to here. Then again I will compare 5 and 3. So 5 is big. Then I'm going to move the pointer here. Then again I'm going to compare 2, 3. So 3 is bigger, right? So I will move it to 3 here and move this pointer to here, and so on. You got the point, right? 6, 5, 3 already went there. At the end, there will be some pointer left in the j num2, and whatever pointer left here without going to 0, we just have to, and wherever the pointer here in I just have to replace that at the end, making it 2, and we're gonna get that particular answer. So let's try this solution now. So let's convert this one is merge 2 and this one is merge, so that we can use the same test cases for this one for development. But here let's okay, that's fine. So now then, first we're gonna create is again we're gonna, in the first merge test we used to initiate our ij with 0, but here we're gonna initiate our ij with the m and n, right? So let I and j equals to m minus 1, the last index, and n minus 1. But again, if for conditions where m is 0, it will become negative. So if I less than 0, then I equals to 0. We're gonna initiate that. Same ways, if j less than 0, j equals to 0. Now again we're gonna start the while loop same way we used to do here, but again we start in opposite way. So we're gonna say while I greater than equals to 0 and j greater than equals to 0. Then we're gonna check if, right, if nums of I is smaller than nums2 dot j, then we have to find the last element, because our zeros are at end. So let's derive our length as well. Let len equals to nums1 dot length minus 1. Okay, and here if the given index value of the array 1, like num1 array, is smaller than the num2 array j, then we have to replace the last element of the first array, that is so nums1 of len equals to nums2 dot j, and we have to move our j pointer, j minus minus. Second condition will be our else. If ith one is bigger, then we have to move the ith, like the value, to the 0 value in the ith array itself. So that will be like nums of len equals to nums1 dot I, and we have to do I minus minus. So it will move, but again our j will be there, right? In both cases we have to reduce the length, remember, and once we put the value, we have to move the length to also left. And minus minus, yet we have to do length minus minus. So the insert position will be in right place. Once we insert one value in the 0 or in the zeros, we're going to move the length pointer, so the next time when we're going to insert, it will insert in the proper place. Now at the end, right, at the end there will be j values. J values will left. So if while j greater than equals to 0, so if j value left, if j is more than 0, it means not all the values in our ith array got replaced. So we have to put the j nums2 to value, those are smaller, into num1. So we just have to do like nums1 of j equals to nums2 dot j. We are just replacing it, because if something left means we know that the jth array are jth means the nums2 array are smaller now than the nums I array, so we just have to replace it, because I already become 0 in this particular case. No, I don't become 0, but it is a case where the smaller values, for example, let me show you the test case. Maybe I have it. No, I don't have it. Let me get you the test case. It is not there. So basically this is a test case where your 4 5 6 0 0 0 0 0 0 3 2 3 4 3, in this kind of test cases, right, where the nums1 has the greater values. So first it gonna see it, let me show you here for better understanding, right? Think about this. For these test cases, we have 4 5 6 0 0 0, right? Another one is like 2 3 4. In this case, when you start our pointer here, it's gonna keep replacing, like it will become 6, it's gonna become 5, it will become 4, but our j pointer will not gonna move. J pointer will still gonna 3 0 1 are gonna stay at 2. So at the end, if j pointer leaves stays, then what you're gonna do, we just have to replace this with the jth numbers 3 2, and this will become our desired array because we already shifted the numbers. That's what the logic is. So it's like 2 3 4 4 5 6 should be like this. Anyway, so yeah, then j minus minus, this should do the trick, you know. You don't have to return anything because the question looking for the but let's test in here. Return nums1. So now let's go here and run our tests. There is a 0 somewhere. Okay, I added more zeros here. There will be only 3 zeros. Perfect. See, now let's see, let's paste this solution in our code and see it. What is the wrong answer here? Okay, we don't have to do 0, only we have to do it for I. Run. Perfect. So now we're gonna submit this. You see, this is one of the efficient one solution. So thank you very much.